In this video, we're going to take a look at difference quotients and how to evaluate the limit of a difference quotient, because this is a really important idea in section 2.4. There's an argument you could make that this is the most important idea in this whole class, so it's really important that we get a good idea. In this section here, we're just trying to get a bit of practice working with difference quotients and evaluating limits of difference quotients. So a difference quotient is, for any function f of x, we have f of a plus h minus f of a divided by h. Here a is just a stand-in for some arbitrary constant, right? So a could be 2, 3, 4, 5, whatever you want it to be. So this expression is called the difference quotient, and oftentimes I want to evaluate the limit as h approaches 0 of a difference quotient. So you could do it all at once, and if you have good algebra skills, there's nothing to stop you from doing that. But these problems tend to be a little bit longer, so I think it's easier and more helpful to take this problem and break it up into smaller steps. So I'm going to break this up into 4 steps. This first step here, I just need to find f of a plus h and simplify that. So oftentimes this is the step that involves the most work, so you will have a little bit of algebra to do here. Step 2, we subtract f of a from step 1. So this f of a, you're actually going to have to find this first, and we'll talk about how to do that. And then you're just subtracting that from step 1, and hopefully you say, hey, f of a plus h minus f of a, that looks a lot like our numerator right here. So we're just trying to build this difference quotient up kind of one step at a time, and then at the very end we'll just take the limit of it. Step number 3, I want to divide step 2 by h, so here's where our h is coming into play, and then that gives us the whole difference quotient right here. That's everything that we need. And every single step along the way, right after step 2, after step 3, we want to be simplifying these. The more work we do in the beginning of the problem means there's less work for us to do later. Lastly, step 4 here, we just need to take the limit of step 3. So at that point, we've got the difference quotient. The only new thing that we're adding in is this limit statement right here. So let's look at an example. Here I've got a simple linear function. F of x is 3x minus 7. I would like to find the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. So let's just hop right in. First step here, I want to find f of a plus h. So in this case, 2 plus h. Here my a is simply just 2 here. So I'm going to find f of 2 plus h. And the way I'm going to do that is I'm going to take 2 plus h, and I'm going to take this and I'm going to plug that in for my value of x inside of my function. If I have more than one term with x, I'm going to plug that in more than one spot. So here I'm going to have 3 times 2 plus h minus 7, and I'm just going to try and simplify this as much as I can. So I'll distribute my 3. Let's see, I've got 6 plus 3h minus 7. So let's see, I've got negative 1 plus 3h, or 3h minus 1. And as soon as you get to a point where you can't simplify this further, you can't combine any like terms or anything like that, that means you're ready to move on to the next step here. So the next step, I want to subtract this f of a right here. So remember we said a is 2, so really I want to find f of 2 here. So I'm going to find f of 2 first, and then subtract that value. So f of 2 here, again, I'm just taking 2, I'm plugging it into my function for f of x right here. 3 times 2 minus 7, I've got 6 minus 7, which is negative 1. So I want to end up with here f of a plus h minus f of a. So I always like to write out kind of what's happening in my difference quotient. So what I'll have here is f of 2 plus h minus f of 2. So f of 2 plus h, we found that in the last part right here. That's negative 1 plus 3h. So negative 1 plus 3h minus f of 2. Just be careful with your signs here. Minus, I really have a negative 1. And I want to take this, I want to simplify it as much as I can. So here in this case you might say, well, minus a negative, that's plus a positive. Negative 1 plus positive 1, these two cancel. I'm left with just 3h. Again, if you can simplify, you should. Step number 3 then, I want to take this result and divide it by h. So let me do that in a different color here. Step number 3, I'm going to take this result and divide it by h. So again, I always like to write out what I'm doing. F of 2 plus h minus f of 2, take that whole thing divided by h. So this piece right here, this numerator, f of 2 plus h minus f of 2, we already know what that is. That's 3h. So this is 3h divided by h. In this case, it simplifies really nicely. The h's cancel, and I'm left with just 3. Step 4, then, is to apply our limit statement. Now, this is the last thing that we need to do, is we need to take the limit of whatever we found in step 3. So in step 4, let's finish that up right here. I want to take the limit as h approaches 0 of whatever I end up with, but that was just 3. So of 3, well, 3 doesn't depend on h, it's just a constant. So no matter what, I'm going to get back 3. And hey, there's my answer. So linear functions are, I actually think they're kind of deceptively simple. They're almost so easy that they're a little bit more difficult. So I think a quadratic is probably a better example to show you the difference quotient here. So here I've got another function, g of x. This time g of x is x squared minus 3. I want to find the limit as h approaches 0 of, this should be g of negative 2 plus h minus g of negative 2 divided by h here. My apologies for that, so maybe I'll just write that out over here. Limit h approaches 0, g of negative 2 plus h minus g of negative 2 divided by h. So I'm going to start off here. Let's start off in blue. Start off by finding g of negative 2 plus h. So that means, hey, I'm taking negative 2 plus h, and I'm plugging that into my function for x. So I have negative 2 plus h squared minus 3. And this one has a little bit more work involved. In one word of caution, I'll say a really easy mistake to make. Remember, I can't just say that this is negative 2 squared plus h squared. I do have to say, you know what, to square something really means to multiply that thing by itself. So I'm going to take negative 2 plus h and multiply it by itself, minus 3. So here you will have a little bit of work to do. We're going to have to FOIL this out, and when we do, I should end up with, let's see, 4 minus 4h plus h squared minus 3. And we say, okay, well, we've got a like term there, 4 minus 3. I can say that's 1 minus 4h plus h squared. Once I get to a point where I say, well, this doesn't simplify any further, that's it. I'm ready to move on to my next step. So step 2, I want to find, let's go find what g of negative 2 is so that we can subtract that. So here in step 2, I'm going to find g of negative 2. This is negative 2 squared minus 3. 4 minus 3 gives me 1. And okay, so I want to subtract this value from what I just found. So g of negative 2 plus h minus g of negative 2. So this first guy right here, g of negative 2 plus h, that's what I found at the end of step 1. So that is 1 minus 4h minus h squared. And as for g of negative 2, that's the piece that I just found by plugging in negative 2 to my function, so minus 1. And again, well, we have 1 minus 1, our constant terms cancel out, and this time we're left with negative 4h plus h squared. So again, I can't really simplify this any further, so I think we're ready to move on to our next step. So next, I'm going to take what I found, and what I found so far is g of negative 2 plus h minus g of negative 2 all divided by h. This is negative 4h plus h squared divided by h. Now, if you look up above, if you look at kind of how this limit is defined, and here you're always going to have this h in the denominator, and 9 times out of 10, your goal is to get rid of that h. We want to try and find a way to get rid of that h. Most of the time we can use something simple like factoring. In very few cases we will have to turn to other methods, but in this case it works out pretty nicely here. I can factor out an h from my numerator. So let's look at h times negative 4 plus h all over h. These two cancel, and I'm left with negative 4 plus h. So to finish this problem up then, I'm going to, for my step 4, take the limit of whatever I'm left over with. The limit as h approaches 0 of negative 4 plus h, because that was what I was left over with in the end of step 3. So here this works out really nicely. I just plug 0 in for h, so negative 4 plus 0 gives me negative 4 as my limit. So there's probably only a couple of these in the homework exercises, but I do think it's a good idea to make sure you practice them, make sure you understand them, because these are skills that are going to reappear in a few sections when we start to talk about the derivative. So it's really, really good practice for skills that will be coming up in just a couple of sections.